wait a minute, that wasn't supposed to happen. So here's the thing, I really like hammers. Some of these I made myself, the others I bought over the years. However, I'm not here to insult your intelligence. I'm pretty sure most people know what a hammer is. The point is, it's a great tool, and seems to be a rite of passage for any machining channel, so let's make one. I'll start off with the head. First I'll face off both sides of the stock and get a measurement of how much material I need to remove. I'll swap to a carbide insert with a larger nose radius. Polished inserts work really well for a good finish, but removing loads of material with them gets expensive rather quickly. Since the point of a dead blow hammer is to have loose meat inside it, I'm going to need to hollow it out as much as I can. Time for the boring part. I know, settle down. Having so much stick out on a boring bar is quite frankly a terrible idea, and I would not advise doing this. Needless to say, safety squints were engaged throughout this part. The trick up my sleeve here is the solid carbide boring bar. Whilst by no means a foolproof solution, by taking really light cuts I should be able to get away with this. Through the magic of editing I can give you a false sense of speed here. In reality this one step took about 3/4 of an hour. Alright, let's measure for taper. Just make sure you don't get the bore gauge stuck in the... Yep, just like that. Around 45 microns of taper over 60mm. It's not bad at all. Let's keep going. I'm aiming for 24mm on the inside diameter. Yep, that should do nicely. Now I'll add a small undercut so that the striking face is thread up all the way. Time for something that anyone with a mini lathe dreads the most. Change gears. I'm setting up the lathe to cut a 1mm pitch thread. Strictly speaking, it doesn't need to be this fine, but when we get to making the striking faces, the fine pitch should make a bit more sense. Alright, let's blow up the part and start cutting the threads. My lathe doesn't have a thread dial, so I must keep the lead screw engaged the whole time. This makes the process rather tedious, because I have to run the lathe in the reverse every time I want to retract the tool for the next cut. As you can clearly see through my hand, I'm checking the scratch pass with a thread gauge. Since I don't really have a way of testing the fit of the threads, I'm cutting them to a specified depth from an online calculator. Strictly speaking, this is likely to make the threads wrong, but since I'm making both the male and female threads, it shouldn't actually matter. It's been a while since I used a forge or chuck, so my dialing in skills are rather rubbish. Here the procedure is much the same as the other side, so I'm just going to skip through this. And back to the 3-jaw again. Time to make the striking faces. I've chosen to use aluminium for the hard face and delvin for the soft face. I originally wanted to use copper instead of aluminium, but the material cost combined with the idea of single point thread cutting, it put me off the idea rather quickly. The power crossfeed really does leave a nice surface finish on aluminium. And this here is exactly why I chose a fine pitch thread for this part. Since I have to stop the lathe before the carriage rams into the workpiece, I was slightly on edge doing this. The fine feed gives me a little bit more breathing room in time to react. Now I can use the head to test fit the threads. Yep, that feels great to me. And of course, let's not forget the obligatory chamfer. Onto the other striking face. Here's the same story as last time. Face, flip the part, face again, then reduce the thread to section. I really love machining delvin because the lathe doesn't even notice that it's there. I can basically get away with big lathe-sized cuts. Alright, I'm sure you get the gist of this by now. And another snug fit. Perfect. Back to the 4-jaw. Again. I really wish I had one of those Tony style 4th dimension chuck switches. Alright, we're nearly there now. Let's reduce the material down to the final dimension, which will also give me a nice surface finish across the part. Just a quick pass with some 280 grit emery paper, a facing cut, chamfer, and we're done. I still need to drill and tap the hole for the handle, but we'll do that later on. And speaking of the handle, let's make that. Except that I can't. As you can see here, I have an M12 by 1 die, but my die holder is too small for it. I guess it's time for a quick side project. The part is too big for the inside jaws of the chuck. Actually, let me try that machinist YouTube trick. Nope. What? There we go. There's nothing particularly interesting about this, so I'll just skim over the highlights. I'll bore out the centre to fit the die, skim the outside to clean it up, add a few chamfers for good measure, and part it off. Simple, right? Well, almost. And now a tabbed hole for the retaining grub screw and two for the handles. And yes, I'm using some M8 bolts I found in my spare parts drawer. It's not pretty, but it works. Okay, finally onto the handle. I'll start by drilling a hole in the centre to support the part, glue the part up, then cut the threaded section that will screw into the hammerhead. A chamfering tool so early on? Interesting choice. Wait, what are you doing? Stop! Stop! The penny drops. Luckily I caught myself in time to realise that I was working on the wrong end. Whoops. I'm using a half dead centre here since it gives me a little bit more room to come in with the facing tool. This is 304 stainless steel and it takes the thread surprisingly well. Lastly, a small undercut for the thread to seat properly. Let's reduce the diameter now. Whilst this is cutting surprisingly well, each of these passes took about 5 minutes, so once again, let's speed through this. I'll take a very light finishing pass to get a nice surface finish, and of course the obligatory stainless steel bird's nest. And lastly, we can't forget the chamfers. These next parts are purely aesthetic and mostly serve to break up the knurling pattern, which I'll do next. Now, I'll be honest here. My luck with knurling seems to be based on chaos theory, positioning of the moon, and what colour socks I'm wearing. The first section of the handle came out as a really fine knurl, yet the bottom part of the handle, which you'll see in a moment, came out as a coarse knurl. I have absolutely no idea why this happened since the diameter of this top was the same. Perhaps I should make one of those Hemingway knurling tools after all. See? This bit came out perfectly. Very strange. Since the last parting operation went so well, I've saved you the misery and did this one off camera. Alright, onto the home stretch now. Just need to drill and tap a hole for the handle. I'll add a small counterbore to blend the handle into the head. I really need to clean this mess up. There we go, much better. If you watched my previous video, you probably know where this is going. The cold bluing will add a nice colour contrast to the part and also serve to protect it from rust. The procedure is much the same as last time, except this time I'll try a method I learned from Artisan Makes, which is to use a Scotch-Brite to remove the first coat of blue and to apply a second one. Also, this time I'll leave the oil to soak in overnight. I must say I'm actually really impressed with the result. Alright, let's put it all together. I originally planned to use lead shot for the meaty inside the head, but as it turns out, lead shot is rather difficult to get in the UK, so I've decided to use 0.5mm ball bearings, around 35,000 of them in fact. Yep, that's definitely a hammer. So, we meet at the healing mat once again. At this point you might be wondering why I made a hammer in the first place, since I've got a handful of them already, and quite frankly it's a bit big for what I would use it for. Well, here's the plot twist. It's not for me. I'm a strong believer in the gift of giving, and this is quite a strong case for it. University taught me many things, but above all else it also gifted me some of the best friends anybody could ask for. This dashing young chap is Tom. We bonded through our mutual love of cars and soon enough became very close friends, a title which I still hold dearly to this day. Tom works at a place called Coastal Motorsport, where they do all kinds of crazy stuff with cars, not least of all, race them. In fact, they have a YouTube channel called Rock Up Racing. I won't spoil it, but it's definitely worth checking out, so I'll leave a link in the description. This is their logo that I sketched and 3D printed. I also made some keychains for good measure. Everybody loves keychains. Oh, and here's the plot twist again. He has no idea I'm actually doing this. Alright, well, we're pretty much done here, so I'll wrap all of this up and send it over to Tom. If you enjoyed this, I would greatly appreciate you dropping a like and a comment, and if you'd like to see more of this, please subscribe. Anyway, thanks for watching. See you next time.